Okay, we're back again. We have a rational function example, kind of a simpler one, but still a lot of work because of this complicated formula. So once again, okay, what we're going to do is we're going to calculate the definition of derivative. We're going to calculate the derivative, by the definition of derivative formula, which once again we'll write out the limit as h approaches 0 of f of x plus h minus f of x over h. And this one's going to be a little bit different because we have a fraction. It's going to be fractions within a bigger fraction. So there's going to be some sort of algebra that's a little bit different. Okay, but once again, okay, we keep writing limit. We write an h on the denominator, and we have our two equations. We have f of x is just the equation we're given, and the f of x plus h is the equation we're given, but we replace x with x plus h. So we have something like that. And again, in this particular example, okay, because there's not a binomial in the second term, it's just one term for each one. The brackets are maybe not necessary for this one. You can leave them there if you choose to, but in this case right here, it's not like you have to distribute the minus sign, so that's not a problem. And there's also no conjugates to do here because there are no square roots. So what we're going to do is we're just going to tackle this right here. And one technique that I asked you, or I recommended that you use, you don't have to, but when you have fractions within fractions, what I would do is try to write it sideways. All right, so what I'm going to do is I'm going to rewrite this as 5 over x plus h minus 5 over x divided by h. So if I write it like that, it's a little less confusing perhaps. You can decide what works for you, but basically what we have to do is we have to change that multiplication, or that division, to a multiplication and flip over the h. So I now have times 1 over h. And also what I have to do is I have to get common denominators and try to subtract those two fractions. So how do you get a common denominator of x and x plus h? You can't just add on a plus h to the second fraction. Okay, like for example, just say up in the corner here I had 2 over 3 plus 1 over 7. I can't just add 4 to do something like this. Okay, it doesn't really work like that. You got to times each one to get a common denominator of 21. So in this case, okay, what we have to do is we have to basically, in this one right here, make our common denominators of x times x plus h, like this right here. And on the first fraction, we put an x on the denominator, so we have to times the numerator by x as well. And on the second fraction, we times the denominator by x plus h, so I times the numerator by x plus h. Okay, so we have common denominators, so what we can do next is we can put together those two fractions as one. So I have x outside of x plus h, and I have 5x minus, now what I have to do here is I have to take that minus and the 5 and distribute amongst both terms. So I have minus 5x minus 5h. So I get something like this right here. Now, once again, you have things cancel. The 5x and minus 5x can cancel. So what we're going to do is, once again, we're going to come back up here. And away we go. All right, we're going to take a look right here. Keep writing limit as h approaches 0, of course. And we now have minus 5h over x outside of x plus h times 1 over h. And what we can do is we can cancel these h's. From top and bottom, something can cancel. You can do that if it's not part of a binomial. Okay, those things are separate on their own. So we can cancel. So we now have the limit as h approaches 0 of minus 5 over x times x plus h. And then at this point, it's safe to plug in the 0 for h, because you notice right here, okay, you're not going to get a 0 on the denominator. And because I'm plugging in the 0 for h, I no longer have the right limit, so I can just do minus 5 over x times x plus 0, which of course is really minus 5 over x squared. And now I've calculated this, I can say y prime is equal to minus 5 over x squared.